In case of complete AV septal defect, you can see this is left atrium, this is left ventricle, this is right atrium, this is right ventricle. This is right ventricle focused 4-chamber view, apical 4-chamber view. So this is left atrium, left ventricle, right atrium, right ventricle. This one is inlet VSD, this is ostium primum ASD. So ultimately ostium primum ASD and inlet VSD, making this case of common AV septal defect. This is a balanced variety because both are balanced in size. At the taking amount of valve from this one is also balanced. So this is a balanced variety of common AV septal defect. Next image, you see the significant amount of regurgitation across our AV valve. Right side this much, left side this much, almost moderate to severe. This child is 4 years old and did not go to higher center for correction and has developed significant pulmonary artery hypertension. I want to show you. You see this is flow across pulmonary valve. This is forward flow across pulmonary valve, and you can see the pulmonary flow acceleration time, that is only 46 millisecond. You can see this is 46 millisecond. This is pulmonary flow acceleration time. So this is very much reduced, indicating raised pulmonary artery pressure. So whenever this time is less than 70 millisecond, indicating severe pulmonary artery hypertension. So this child has developed severe pulmonary artery hypertension in this case. Now the next image, you can see this is forward flow, this is backward flow. This backward flow is pulmonary regurgitation. This flow is across pulmonary valve. So this is above the baseline is pulmonary regurgitation, and below the baseline is flow across pulmonary valve, forward flow. Blue color is forward flow and red color is regurgitation flow. So here what you see, the highest pressure of PRZ, that is 52 millimeter of mercury. If you add with 20, because in this scenario right sided of a structure is very much dilated, at the same time IVC is dilated, so you have to add 15 to 20 millimeter to 52 millimeter. It will ultimately become up to approximately 70 millimeter of mercury. So that kind of mean pulmonary artery pressure. So peak pressure gives you mean pulmonary artery pressure. So how to calculate mean pulmonary artery pressure? That should be less than 20, or higher side if you go less than 25. Whenever it is more than 25, it is abnormal. So mean pulmonary artery pressure is calculated by the peak velocity of pulmonary regurgitation jet. That is the point I want to share here. That velocity is 361 centimeter per second, or you can say 3.61 meter per second. Ultimately 4 into velocity square, that is 4 into 3.6 into 3.6 will become 52 millimeter mercury. If you add right atrial pressure, you can take 10 to 20. That is, if whenever IVC is severely dilated, not responding with, not collapsing more than 50%, in that scenario you have to take 10 to 20 millimeter of right atrial pressure. So if you add 20 millimeter to 52, then it will become 72 millimeter mercury. So whenever you find more than 50 to 55 pressure of mean pulmonary artery pressure, that will be called severe pulmonary artery hypertension. So this case has got developed severe pulmonary artery hypertension. That is the scenario. So no one should miss. This case should have been referred to higher center below the 6 months of age, so that operation can be timed properly. So that is the scenario. How to calculate mean pulmonary artery pressure? What is normal mean pulmonary artery pressure? That is less than 20. If more than 25, it is abnormal. It is more than 40 to 55, it is moderate. If it is more than 55, it is severe. But you have to add this pressure to right atrial pressure, then that will give you mean pulmonary artery pressure, because formula wise mean pulmonary artery pressure is this pressure plus right atrial pressure. That is the formula. So you have to add 52 and 20 in this scenario. You can add if even 10, you can add even 5. It depends on the size of IVC, right atrium, right ventricle. So you know the IVC is dilated and not collapsing more than 50% with sniff test. That indicates pressure is very high. That is approximately 10 to 20. Average you can take 15 millimeter mercury. Thank you for listening. So this is the case of common AV septal defect, and patient has developed significant pulmonary artery hypertension. You see the pressure across the tricuspid side of AV valve, that is 76 millimeter mercury. You can see. So across tricuspid side of common AV valve, what you see the gradient, that is 76 millimeter mercury, indicating severe pulmonary artery hypertension. Thank you.